Let's start this. Now, let's start answering the table of end behavior. Joseph, would you please?
Okay, so the first step in completing graph is to find if the leading term is greater or less than 0. In this example, you have to multiply all the x's. Negative x times positive x times positive x times positive x equals negative x raised to 4. In this case, the negative sign indicates that the leading term is less than 0. And if it is positive, then the leading term is greater than 0.
Now next is finding the degree of the polynomial function. Now in order to find its degree, we must look at the highest degree of the function. In this example, the highest degree is 4, which means the degree of the polynomial function is even. Number 4 is an even number because number 1 is an odd number, number 2 is an even number, 3 as an odd number, and 4 as an even number.
Your objective is to answer the behavior of the graph and multiply each term, which is the given problem. First, you will use a FOIL method, which is the first, outer, inner, and last term. The first term is the negative x minus 5 times the other term x plus 1. So, the first is negative x times the positive x. Then you will get the negative x squared. The second, negative x times 2 positive 1. Then you will get the negative x. Third, negative 5 times the positive x. Then you will get the negative 5x. The last one is a negative 5 times 2 positive 1. Then you will get the negative 5. And combine the like terms, which is the negative x minus 5x. Then you will get the negative x squared minus 6x minus 5. That is the final answer of this first term. The second term is the x minus 2 times x minus 5. Just like what we did in the first term, you will use a FOIL method, which is the first, outer, inner, and last term. Then you will get the x squared minus 5x plus 2x plus 10. Combine the like terms again, and you will get the x squared minus 7x plus 10.
Next step. Multiply the two products using FOIL method. If you multiply negative x squared minus 6x minus 5 times x squared minus 7x plus 10, you will get negative x raised to 4 minus 7x cubed minus 10x squared minus 6x cubed plus 42x minus 60x minus 5x squared plus 35x minus 50. To make it easier, arrange it on a form like this. Same degree will be added to each other. You will bring down negative x raised to 4, positive 7x cubed plus negative 6x cubed. The answer will be x cubed. Negative 10x squared plus negative 5x squared. The answer will be negative 15x squared. 42x plus negative 60x plus 35x. The answer will be 17x. Negative 50 will be bring down.
Now we go on the behavior of the graph. Both left and right side of the graph. The right side of the graph is depend on the leading term. In our case, a sub n is less than 0. That's why the direction on the right side of the graph is falling. On the other hand, the left side of the graph is falling because the degree is even. If the degree is even, both left and right have both direction. That's why left side is falling and the right side is falling.
The next one is our possible sketch. As you can see in our sketch, it has 4 turning points. Do you know why? Because we multiply the 4 terms, that's why it has 4 turning points. And it started with falling because our leading term is negative. But if our leading term is positive, it will start on rising. Let's try doing the sketch. Falling 1, 2, 3, 4. It also ended with falling because it has an even degree. And this is our possible sketch.
Now let's move on how to get the x and y intercepts. To get the x intercept, we need to transpose the terms. To get the y intercepts, we need to multiply the terms like this. Negative 5 times positive 1 is equal to negative 5 times negative 2 is equal to positive 10 times negative 5 is equal to negative 50. And that's the y-intercepts.
Now that we're done in the table of and behavior, we will now proceed in the graphing section of this equation. Before we start graphing, I want to refresh your mind about the Cartesian plane. The horizontal line is called x-axis. The vertical line is called y-axis. And there are 4 quadrants in the Cartesian plane. Quadrant 1, Quadrant 2, Quadrant 3, Quadrant 4. Now, we can proceed in the graphing of this equation. The first is you need to plot all the points in this graph. For you to plot all the points, you need to put a certain value in the Cartesian plane. Remember the x-intercept and y-intercept has a value. The y-intercept has a value of negative 50. And you need to put a certain value up to 50 in the Cartesian plane. In this, we can use skip counting, so I skip count it by 5. You can skip count it by 10, 25, or even 50. But in this case, I use skip counting by 5. So gold, skip count with me. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. We have all the values in the Cartesian plane. We can now plot na to. The x-intercept that Balisi got earlier is negative 5, 0. So we can put it here. Negative 1, 0. 2, 0. And 5, 0. As for the y-intercept, Balisi got 0 and negative 50. So we can put it down here to connect or to draw a line between points. So we can start at quadrant 3 or quadrant 4, or you can start quadrant 4 to quadrant 3. But in this case, I will start at quadrant 3. So we will draw a line that goes up to negative 5 and will go down at negative 1 and then up to negative 50. The negative 50 will be our turning point, and it will go up again to 2 and will go down to 5. And there you will have the graph for quartic equation. As for the quartic equation, if the equation is negative, it will look like an M. And if it's positive, it will look like a W.
Graph is an example of a quartic function. Why? Because the degree of the leading term in negative x raised to 4 is the 4 itself. And we all know that in polynomial function, if a variable has a 4 degree, it is called a quartic. That if it has 3, it's cubic, 2 quadratic, and 1 is linear. Now, let's move on the behavior of the graph. As you can see, the right side and the left side of the graph is both falling. Now, I will explain to you on just how did this happen. The right side is falling because the value of the leading term is negative, which is negative 1 in negative x raised to 4. While the left side of the graph is also falling because the leading or the highest term, highest degree of the polynomial is an even number, which is number 4. Now, this explains that the both sides of our graph is both falling. Now let's see if the graph and the possible sketch we made is the same. This is the graph. Okay, 1, 2, 3, and 4. This is the possible sketch. 1, 2, 3, 4. Actually, we are doing a possible sketch to assume what will it looks like if we graph it. As you can see, the possible sketch and the graph we made is the same. Now, we prove that the graph we made and the possible sketch are correct.
We therefore conclude that in this table of end behavior, the leading term would be less than 0. The degree would be even because the polynomial function is quartic, meaning its highest degree would be 4. The behavior from left would be falling, then to the right is the same, it's falling. The possible sketch would be this: 1, 2, 3, 4.
I rest my case.
Ooh!